All right, let's go ahead and get started. Welcome to the Home and Energy Chats webinar series and our episode about building science. My name is Heather Chandler, and I am the owner and publisher of Green and Healthy Maine Homes. We have a fantastic presentation tonight with two of the experts, certainly in Maine and also making a name for themselves across the country. So I'm very excited to have them here. I would like to start with a special thank you to our sponsors, including our spring season sponsor, Senecal Construction Services. They are now offering net zero ready design build packages in Pownell, conveniently located just minutes from Portland, Freeport, and Brunswick. And a word from our presenting sponsor, Royal River Heat Pumps.
Hi, I'm Scott Libby, owner of Royal River Heat Pumps. A long time ago, the Royal River, like most rivers, was an important part of life, powering mills and allowing a community to grow and flourish. Nowadays, we see what a river can help to create. We believe that ordinary people can come together to make a big difference too. This year, Royal River Heat Pumps will invest our advertising dollars into a new campaign we've launched called Ripple to River. Each month, we'll choose a different nonprofit organization whose focus is kids battling childhood illnesses. We'll tell you about their particular mission and let you know how you can help support them. We're also launching an online resource at rippletoriver.com, providing information and a link for donations. Little things can turn into big change. I'm Scott Libby from Royal River Heat Pumps in Freeport, and I hope you'll join us in making change happen for kids and families that are facing challenges that nobody ever wants to face. Visit rippletoriver.com to learn more and donate, and thank you.
Thank you to both of our Home and Energy Chat sponsors. A quick overview of the evening before I do official introductions of Steve and Dan. We will begin the webinar shortly with a presentation, and we're going to mix it up a little bit tonight and intersperse some of the time for questions throughout the presentation. So if you do have questions right away, feel free to enter them using the Q&A feature at the bottom of your screen. We did get quite a few during the registration process, so we will do our best to get to all of them. A reminder that the webinar is being recorded and will be uploaded to our website, greenmainehomes.com, later this week. If you are not familiar with us, Green and Healthy Maine Homes is dedicated to inspiring healthy, efficient, and future-ready Maine homes through a quarterly print magazine, the annual Green Home and Energy Show, which will be April 6th in South Portland next year. We also produce an online directory of professionals in the green home space, helping you create healthy, efficient, and affordable Maine homes. So please check us out at greenmainehomes.com. And now it is my pleasure to introduce our two panelists for the evening, who both happen to be on our advisory board for Green and Healthy Maine Homes and have been from the very beginning. And believe it or not, we are about to celebrate our 10th anniversary in the spring. So that's been a long time that we've been working together. So I'm very excited to have you both with us tonight. Dan Kolbert of Kolbert Building is co-author of the Pretty Good House book, A Guide to Creating Better Homes. We do have some signed copies available. So if you are interested in ordering one of the signed copies, reach out and we can make plans to get that to you. Dan has facilitated the monthly building science discussion group in Portland since 2009. And as I mentioned, he serves on the board of Green and Healthy Maine Homes. And Steve Konstantino is founder of Performance Building Supply, which opened in 2002 with a mission of helping builders build better by sourcing superior products and technical information to supply to construction professionals. He also co-founded the Building Science Discussion Group with Dan. And as I mentioned, serves on the advisory board. So it is a pleasure to have you both with us tonight. And at this point, I'm going to turn it over to you, Dan.
Thanks. Yes, Steve and I have been talking about building science for a long time now. Somehow we keep finding new things to say about it. So, okay, I'm in charge here. this is something, hopefully you could just read it yourselves. This is just a definition I found online of building science, which I think is just a helpful framing. So I will give you a second to read that. I'll whistle to myself, hum something. As you're finishing that up, I'll just say, there's two things I want to say about this. One is that there is the shorthand version of what they're saying here is house as a system, which is a phrase we often use in building science, meaning that there's a lot of parts. The more demands you're making of the house, the more all those parts need to work together. So your insulation needs to work with your heating system. Your heating system needs to work with your windows. All of those things need to work with keeping water out of the building. So that's what we mean there. The other is that building science implies that we are scientists, meaning we are doing experiments. And sometimes we screw up or whatever, or sometimes the experiment turns out to have been a bad idea. So we are one of the important elements about being interested in building science is approaching it as a science and being willing to make corrections when you realize something was not the best approach, and also monitoring your projects, making sure you stay involved, that you have some way to make sure that things are actually performing as you modeled them, as you designed them. So this is just basically breaking it down. These are the things that we're looking for when we're talking about building science. So we have recently, in the last few years, started talking about the house in a way that makes it, I think, a lot easier both to talk about and to understand, which is talking about these 4 control layers that go into how a house performs. The first is your weather or water control layer. This is the most important, keeping bulk water out of your house. If your house is leaking, it doesn't really matter how wonderful anything else is. It's going to rot and rot quickly. So your weather control layer starts, if you're, from the roof, if you're starting from the top down, the roof is a critical element, perhaps the critical element of keeping water out of your house. Your siding and also what's beneath the siding, this we call it the WRB, weather resistant barrier. Probably a lot of you are familiar with Tyvek, the white membrane that we staple up on houses, but that's just one of many, many different kinds of membranes out there. But they all essentially are trying to keep water out. Then things like your windows, right? You want to make sure your windows are both built well, installed well, and flashed well to keep the water out from there. Things like waterproofing your basement, anything that's involved in keeping actual water, standing water, rain, any of those things from coming into your house are part of that layer. And as Heather said, please, I'm going to go through these 4 layers, but I'm happy to stop at the end of each one if people have specific questions about them. This one I hope is the least mysterious of the 4 as well. So you can see, right, these are just, again, this is roof. This is 2 different systems on the same house because this was a house that we tore. This was a ranch that we put a second floor on. So on the first floor, we had the original old board sheathing. So we put this Hydra Gap on, which is a self-adhering house wrap, which does a nice job of air sealing old boards and things like that with a lot of gaps. And on the second floor, we use Zip System, which I'm sure if you drive around, you've seen many times. The green coating is a weather-resistant barrier, and the tape on the seams is what sort of seals it all up. This is a foundation waterproofing. There's different kinds. There's like the stuff you paint on, the asphalt that you kind of paint on, and then this is actually a physical barrier a dimple mat, which is waterproof and also has these dimples in it, which helps reduce the amount of pressure that standing water can apply toward your building. And then this is even trying to keep water coming up from below. We are painting on a capillary break on top of our footings before we pour our foundation walls. Water can rise many, many feet in a concrete wall because concrete's very porous. It's a big sponge, and also because of groundwater pressure. So by painting this on, we make it much harder for water to get from the ground up into those walls. So the next layer is the air control layer. And it's important to point out that one product can fulfill multiple roles. For instance, going backwards, the zip system often is both your WRB, your weather control layer, and also your air control layer. The tape that you put over the seams does a very good job of air sealing the panels, and then you have an air seal. But this is a project where the air seal is on the inside of the house. I can't remember if this is my job or somebody else's, but anyway, this is a product that Steve sells from Siga, a Swiss company. And it is a product that is an air control layer and also a vapor control layer, which we'll talk about shortly. The tape is to make sure that it's all sealed, air sealed well, because if it's a leaky air barrier, it's not doing its job. So the reason why we want an air control layer, there's several reasons. The first is for comfort. A drafty house is not particularly comfortable. The second is energy efficiency. A drafty house is replacing all that nice warm air in the winter with very cold air. And in the reverse in the summer, if you've got your air conditioning running, you're losing your nice dry, cool air and bringing in hot, humid air to replace it. And the third reason is that air, after bulk water, air movement is the largest source of water problems in a house. Air carries a lot of vapor in it. And if that air is passing into your assemblies, meaning your insulated walls and ceilings, it's bringing that moisture with it. And it can easily condense and start to cause problems, either rot or mold or decay or any of those things. So those are the three big reasons why we do an air control. An air control layer you can have anywhere. It's best if it can be protected to make it that much harder for future occupants to puncture it. And you can have multiple air control layers. It's good to have continuity of your air control layer because bypass, if it's sort of coming up the outside of the wall in one place and on the inside of the wall in another place, those intersections are often very leaky spots. But there's no reason why you can't have, zip system on the outside and then drywall on the inside, which is a pretty good air barrier too. There's no danger to multiple air barriers, which is not true for vapor barriers, which we'll talk about in a minute. No new questions?
I do have some questions on the first layer. Do you want me to jump in with them now?
Sure.
All right, so this is about a frost protected foundation. So what is the depth needed for a shallow frost protected foundation in southern Maine for an unheated building?
For an unheated building. I don't know that there's particularly a depth, Steve. Do you? I mean, the whole point of a frost protected foundation is that it's doing its own work.
Usually they're haunched at the edge of about 16 inches
right.
of concrete, and then you're supposed to put a wing to the outside to keep frost from going under it. So you have a foam layer that's going out from the side of the foundation, from the side of the slab, basically, that with a little bit of a slope on it that keeps the frost from driving underneath.
Yeah, but I don't think the depth, I think the R value is probably more important than the depth itself, right?
Correct. The depth would be more about what the load is going to be on the whole thing, the structural load, right?
Yeah.
Okay.
Anything else?
A few more. So this is more of a general question. I think you are going to be covering this throughout, but I will share it. It is looking for the healthiest and most sustainable options in that order for creating high performance envelopes in renovation.
Well, that's an easy one. Um, well, I have to admit, I don't really know what's sustainable. So I can't answer that one too well. I assume that what they're going for is low environmental impact, which is about the best I can offer. Um, I think it's kind of like food, right? It's like processed food. The same is true for building materials. The less processing, the better. Um, every process requires energy. And so the more energy we use to create the house, the more of a carbon footprint we have right from the beginning. So wood isn't necessarily, wood can be carbon negative, meaning it's actually storing carbon. But that is a very complicated issue that is much debated. But certainly wood has a very low carbon impact, unprocessed wood, 2x4s, whatever. Um, as you get more sophisticated, plywood obviously has more embodied carbon than a 2x4 does. But it's still better than using, whatever, very synthetic product. Um, your insulation, it can be a big driver of carbon. Things like cellulose and the new Timber HP product they're making in Madison, Maine, are very low to negative carbon. Um, things like polyurethane spray foams, um, and other, chemically produced products tend to be much higher carbon. We are certainly, the manufacturers are doing a good job of lowering the carbon footprint of those products, but it's still always going to be sort of inherently higher than something like cellulose, just by the nature of the beast. Plus, they're nasty, and they're not very safe for the installers. Um, there's no. I guess I always say, I mean, for new construction, I I think we are always pushing size as the biggest driver, right? The smaller, the better. Building a bigger house than you need is going to use a lot more carbon and have a much higher environmental impact than many of the things you might fill it up with or build it out of. Anything else you want to throw in there, Steve?
Yeah, I agree. Wood and cellulose versus steel and foam. If you can reuse things, if you can refinish your cabinets if they're in decent enough shape versus getting new cabinets,
Right.
you know, cleaner finishes are always a good choice too.
Yeah.
And there's a lot more options out there for that, paints and floor finish and that kind of thing. But yeah.
In terms of occupant health, if that's part of it, which I imagine probably is, there's a few things. Again, what you fill your house up with is going to have a huge impact on your health. Most manufacturers have gotten much better about VOCs and formaldehyde and all those kinds of things. But still, the less processing that goes into a product, the less chance that it's going to be off-gassing nasty stuff. And ventilation. I mean, indoor air quality is a huge topic. It was a big topic in the construction world before COVID. And since COVID, I think it's become a big topic for the entire world. And it's good that it is, because it's a serious subject that we have been ignoring for far too long. And indoor air quality generally is pretty bad. So ventilation systems, filtration, all of those things are very important. We are learning more. The more we look into it, the more we're learning, about how important they are.
There are a couple last questions on this that have to do with the effects of pressure washing on potentially introducing water into insulation, attic, One concern is that the insulation R value will be reduced as the insulation is wetted down, reducing R value. And then the other one related to pressure washing vinyl siding from the ground level. Concerned that the 3 weep holes at the bottom essentially isn't enough to let the water out. Any comments on that?
Well, the first part, yeah, I mean, you certainly don't want to inject water into your house, if you can avoid it. It depends, plenty of insulation, houses get wet, they dry out. Especially if it's a drafty house. So you need a little more information to know if it's how much of a problem it's going to be. In terms of the siding, I guess I wouldn't worry so much about that. Vinyl siding sits very loosely against the house. There's plenty of room behind the vinyl siding for water to move and escape from the building. So I think if you can pressure wash your vinyl siding and get another 10 years out of it or whatever, then I'd say that's terrific.
Yeah, if you can spray, if you're going to power wash, if you can spray downward instead of upward, it's always better on the siding. And then it's also about how well the siding's installed, whether there's actually a taped weather barrier behind it, which I find to be pretty rare. You can get a lot of water up behind the weather barrier and into the sheathing, which is oftentimes just an OSB if there's vinyl siding. So it's good to be thoughtful about. I don't think it's great to spray upward into vinyl siding.
Yeah. And, for better or worse, vinyl siding typically comes along with, not great building practices. They're typically not in, it's a budget product that often went along with a budget house. So it just, I think you need to do, I think the questioner has legitimate concerns, but you need to do a little investigating. You need to be a building scientist, I guess, and figure out how exactly the house goes together.
You can always scrub your vinyl siding with a brush.
Right. Exactly.
And then just a regular hose and rinse it down. It's a little more work though.
Right. All right. Is that it?
I think that's it. Back to you.
Okay. So back to air control layer. So this is it. So this is just showing that the drywall is actually an excellent air barrier. It needs to be detailed well though, because typically drywall, starts and stops a lot. So like where an interior wall hits an exterior wall, it's hard to get a consistent air barrier behind that wall. So it takes some thinking, but it certainly can be done. There's a whole process called airtight drywall assembly. This is just showing again that once you reach this is a ERV, a energy recovery ventilator. It's a balanced ventilation system, which means that it has a fan and it's pulling in as much air from the exterior as it's exhausting. Once you get your house to a certain level of air tightness, you really want to have a balance. I mean, we're learning actually even in drafty houses, the ventilation system is not a bad idea. But the tighter your house is, obviously, the more pressing it is to have a ventilation system. And we're also learning that a balanced ventilation system works much better than an unbalanced. For instance, like running leaving your bath fan on all the time is an example of an imbalanced ventilation system. It's better than nothing, but it's not going to. But something like this system is going to do a much better job. All these hoses on the top of the unit are headed off into different rooms. Some of them are supplying air to rooms. Some are pulling air out of rooms and bringing it back. And then basically the exhaust air mixes over. There's a membrane separating the exhaust air and the intake air. But basically, like in the winter when it's cold outside, the warm inside air flows over the cold intake air and pre-warms that intake air before it enters the house, gives up some of its heat energy to that, so that it is not 10-degree air you're pulling in on a January night. And it also obviously saves a boatload of energy that way too. Some of these units, are 90% efficient in terms of the heat energy they can recover. Okay, the next one is also a relatively straightforward one. It's got a fancy name, thermal control layer, but basically that just means your insulation. This is a picture of some cellulose insulation going in. Your windows, you can see these are triple glazed windows in this picture. Those are also part of your thermal control layer, your doors, anything that keeps, that separates the interior conditioned space from the outside unconditioned space as part of your thermal control layer. The code keeps getting better and better in terms of what they require for new houses, but you want to have a lot. Where exactly to stop is another question that's much debated. An energy model is a really good way to figure it out if you're building a new house. An energy model can tell you, well, if you put in, R40 in the walls, this is what you can expect to pay for heating. If you put R50 in, this is what you can expect. And then you can make some informed decisions about how far you want to go.
Can I interrupt you there for a second?
Yes.
If somebody was interested in doing an energy model, who would do that for them? Where would they get that done?
Well, typically, if you're doing a new house, typically the architect will handle that. Energy mod, does like Claire do energy modeling, Steve?
She does I believe. And a lot of times whoever's doing the mechanical system and design is going to have to do some modeling.
Yeah, if you're doing it, if you're building, if you're contracting your own house, getting somebody who's like an energy who does a variety of things, like the person who would come do your blower door test is often someone who knows how to do an energy model. But again, as Steve said, if you've got whoever's installing your heating system may be able to they may do it, or they may know someone who can do it. If you've got an existing house, it's less about energy modeling and more just about getting an energy audit. And there's a lot of people out there who can do that. The same people who I was just describing can do that. But that's like somebody who comes in and looks at your house, maybe does a blower door test, maybe gets an infrared camera and tries to see where the leaks are. And part of their job is to sort of present you with a list of things and say, this is, these first things are where you're going to get the most bang for the buck. That's typically insulating your basement and your attic. And then go down the list from there in terms of improvements you can make. It sort of gives you a good roadmap for things to address over your ownership of the house.
Very helpful.
Yeah. These windows, many of you have probably seen triple glazed windows by now. A friend of ours likes to say the best window is still a really lousy wall. The best windows out there might have there are value compared to a wall. If a wall is like R40 or something, these might be R 8, 9, 10, might be about as high as you would ever get. But that's certainly a hell of a lot better than the R1 that we used to have, or that some windows still are. And it also, the beauty of triple glazed windows is partly the increased U value, and partly just that the surface of the window stays much warmer when it's cold outside. If you've got a double glazed window, the interior glass could easily be in the 40s when it's really cold outside. That extra layer of glass typically means it's going to be in the 60s on that inside surface of the glass. So that's important for several reasons. One is just comfort. If you're standing near the window, you're going to be a lot warmer. Another is condensation. If you have a surface that's 40 degrees and it's nice and warm and relatively humid inside, it is going to condense on that window. And that water, even just the dust in the air or whatever, is enough organic matter to start getting mold growing. So after bulk water, condensation is the big water enemy.
And if you've got a air sealed home, you're more likely to have a higher humidity level as well, which is good as long as it's not too high.
Right, controlled. So this is underneath the house. We're about to pour a concrete slab here, and there is rigid insulation underneath it that protects it from the ground being cold. The ground obviously does not get as cold as the air, but still we want to insulate it. So we don't put as much under a house as we do on the walls and the ceilings, but we still put some in there to keep it warm. All right, then the last one, this is that same house before the concrete with a different model this time. The last layer is the vapor control layer. This is the most mysterious and difficult to figure out exactly what to do. The other three, it's fairly straightforward. There's not a lot of mystery about what we're trying to accomplish. The vapor control layer basically is, as I said before, air carries moisture with it. So we are trying to keep the vapor in that air from moving through our walls and ceilings and causing problems inside of those assemblies, we call it, which is just basically all of the parts of a wall, from the drywall, the inside to the siding on the outside. That's all your assembly, including the framing and the insulation. The tricky part is that, so first of all, vapor, like any other energy, like heat, like pressure, like anything, vapor will move from an area of higher pressure to an area of lower pressure. It's always trying to seek equilibrium. So if you have, in the winter in Maine, it's incredibly dry outside, right? And then it's, whatever humidity level it is inside, it's certainly going to be higher than it is outside. So the vapor drive, as we call it, is going to be from inside to outside. If you're in Atlanta in August, it's going to be hot and incredibly humid outside. And if you have the air conditioning on, it's going to be cool and dry inside. So there, the vapor drive is the other way. It's from the higher pressure outside to the lower pressure inside. The reason that that's an important thing to think about is that you need to decide where are you trying to, if you're trying to control the vapor, where are you controlling it? Are you trying to control it on the outside, on the inside, in the middle? Not at all. Where we used to put up like this 6 mil poly that you see beneath the buoy is what we used to put on the walls between the framing and the drywall. Insulate, then we put this over it. The problem is that if you have the air conditioning on, that drywall and that plastic behind it is the cold surface, meaning that if there's any vapor in your wall, it's going to condense there. Drywall is an excellent food for mold. So there were a lot of problems there with mold growth in air-conditioned houses. Maine is getting hotter, as we all know. We are also putting a lot of air source heat pumps in, which are fantastic. One of the things about them is that they come by nature with air conditioning. The heat pump is just, it's a heat pump that can go in both directions. It can either pull heat from the outside and deliver it to the inside, or it can pull heat out of the inside and deliver it and get it out of your house. So that means that we can have vapor drive in both directions over the course of the year. In the dead of winter, we've got vapor drive going to the outside. In August, we can have vapor drive going to the inside. That has been true for a long time in sort of mid-Atlantic states, even in parts of the South, where it gets cold enough in the winter that people are turning the heat on. So that means that people like me and Steve stay awake at night worrying about are we trapping vapor anywhere in our assemblies where we don't want to. We can keep it all to the inside, and then we've got like an ERV, we've got a ventilation system or a dehumidifier or something that controls it from the inside. We can try to keep it all on the outside, and not worry about it. We could put like put like an impermeable layer, like some house wraps or rigid insulation or something on the outside, and then any moisture that might get past that, if it's vapor open to the inside, it'll flow to the inside. As a builder who worries about all of these things probably far more than I need to, I am increasingly convinced that we probably don't want to trap vapor anywhere, that we want our assemblies to be relatively vapor open in both directions, meaning that any moisture can escape in either direction, depending on which has, which time of year you are, basically, whichever side is drier at that moment, you can send the moisture to that in that direction, either to the outside or the inside. What do you think of that, Steve? Weigh in on that.
Yeah, it gets complicated quick. So my view is the air control layer is definitely more important in most of the assembly. Right there in this photo under the buoy, that is the critical area to have a real vapor control layer where you're not allowing radon and other moisture up through. The walls, I believe in a little more open assembly. I think you do too, Dan. So something that don't worry about the vapor as much as the air. And same into the roof, the attic, or whether you have a vaulted roof. Try to stop air movement, and you're going to control most of that air movement, or most of the moisture movement as well.
Right. So yeah, foundation, concrete. As I said, concrete's a big sponge. The earth is basically an infinite source of moisture. So you know that the vapor drive is always going to be from the ground into the house. So you definitely want a robust vapor barrier there, or you'll have big problems. That's one of the big issues with retrofits, with renovations, especially in Maine. Any basement that's older than 40 years old is probably a wet basement, at least sometimes. And it's hard to control. Unless you're willing to sort of excavate around your entire house, you're not going to solve that problem. So as you air seal above ground, you just need to be well aware of the fact that there's going to be moisture and you need to control it, dehumidification or whatever. But it's very easy to seal up a house and then have big problems because you've got a wet basement. This is another piece of the vapor control layer. So there are a lot of products out there now that do an excellent job of keeping air out, like this Siga product, but is vapor open, meaning that vapor can pass through it. There is something called the perm rating, which measures how porous basically a material is. The higher the perm rating, the more vapor it allows through. So, a perm rating of 1 is pretty low. It does not allow a ton of moisture through. Below 1 is very low. What's it on this product, Steve?
It's about a 15.
Right. Good. So that means that if there's moisture coming, in the dead of winter, pushing out through our walls, it can pass. It's not going to get trapped between this blue layer and the ply and the sheathing behind it. It's going to pass through. The other thing you'll see here is the strapping going vertically on the wall. We're creating what's called a rain screen. That strapping is 3/4 of an inch thick. So there's a big, huge air gap behind our siding. So any moisture that gets through that air barrier, the Siga, the blue stuff, has plenty of room to dissipate between the Siga barrier and the backside of our siding. I think rain screens just are incredibly cheap insurance. I think it can really save your butt. You can really screw up pretty badly, and if you've got a good rain screen, you'll probably be okay. It really and the lack of a rain screen can make a otherwise very good house problematic. That's one of the nice things about vinyl siding, frankly, as we talked about before, right? Vinyl siding is sort of automatically a rain screen because of the way it's made. It's hollow, it's that zigzag shape on the back and the front. So there's plenty of room for stuff to go behind it. But Anyway, there's a bunch of different ways to do a rain screen, but I can't recommend strongly enough that you have one. We are figuring out more and more what is needed, and it's not. At one point, we thought the bigger the better. Now it seems like we really don't need as much as we thought. In fact, let me see. Well, I can't remember that in that first picture with the Vicor with the zip system, the green sheathing on the second floor. We had a product called Hydrogap SA on the first floor, which is basically a membrane like that Sega in the last picture, and it's just got these little sort of rubber dimples on it. They're probably no more than a 1/16 of an inch thick, and it's just sort of like somebody sort of, splattered paint on it or something. And that seems to be a pretty good rain screen. I mean, that seems to do its job reasonably well. So, for instance, in my house, I live in the West End in Portland. It's in the historic district, so I can't really mess with the exterior of my house very much. So I'm re-siding part of the house, and I'm using that product there because I can't really add to the thickness of the house. This doesn't particularly. It adds, as I said, maybe a 1/16 of an inch. So it's not really adding anything to the thickness of the house, but it's getting me a rain screen on the outside of my house. So this product, and I'll probably let Steve handle this because I always get confused when I'm talking about this. There's a bunch of products. Sega makes one. Other manufacturers make other versions of it that are called smart vapor barriers, and basically they operate differently, but they basically all somehow are reacting to changes in humidity levels on one side or the other of the membrane. So, Steve, you want to jump in on this one?
Sure. Yeah, this does get a little complicated sometimes, but the this particular one is bi-directional, so it has a lower perm rating going into that, which would be a ceiling or a roof, and a little bit higher perm rating coming back out of it, back into the room. So if this is what we would call a hot roof, where there's no venting underneath the roof sheathing, you definitely want to do something that's going to allow some drying back into the space. And you want it to be a pretty thick roof layer then too. But that's generally the idea. Most of the other ones will just increase their perm rating with temperature and humidity, but they increase in either direction too. So you want to be careful if you're doing that during construction when your humidity is really high, because you don't really want to get that sort of moisture pushed into your assembly then. But it's really about air control there mostly, for sure.
Right. Yes. Yeah, you can see that whoever installed this did a very neat job. And when this guy's done blowing cellulose in, they'll very carefully tape those holes up.
Yeah, this does look like a Sega marketing photo. So they're always wearing vests in Switzerland whenever they're in a marketing photo.
And nice Oxford collar shirts, very fancy.
Yeah, typical. He looks just like a regular cellulose.
Right.
Like have you ever seen a cellulose installer? They don't look like that.
No, they look like
they're covered with cellulose.
They look like a woolly mammoth when they're done. All right. So before I go to my exciting recap, are there any more questions, Heather?
There are quite a few, actually.
Okay.
Several on thermal layer. One is asking, what can you expect with spray foam in roof rafters and exterior polyiso on exterior? I'm not exactly sure what.
I assume they mean both of them together.
What can you expect? Is that an R value question? Is that a?
I don't know, but Steve and I will jump in as best we can. If they're asking, what can we expect if the assembly is spray foam on the underside of the sheathing and then polyiso, which is a form of rigid insulation on the exterior, the answer is trouble, potentially. We often talk about a vapor sandwich, meaning that you've got two impermeable layers on either side of something that can rot, in this case, the roof sheathing. That assembly cannot dry in either direction. Closed cell spray foam is vapor impermeable once it reaches a pretty small thickness, and so is polyiso. So vapor impermeable sounds like no moisture is going to get through, but of course some moisture will get through. But it's going to have a really hard time escaping. And while it's in there, it's going to start doing damage. So if that's the question, I would say that's a bad assembly. And open cell spray foam would be an even worse decision, because open cell spray foam lets a lot of moisture in. And again, it's harder for it to get out. It will get out a lot slower than it will get in, and will cause all sorts of problems.
I agree with Dan on all that. Never trap wood between impermeable layers.
Right. And, that's one of the tricky things about roofs is that, pretty much every roofing material, with some exceptions, is impermeable. You could do like a metal roof that might not be impermeable unless you cover it with ice and water shield, that sticky bituminous membrane. But most roof assemblies are very impermeable. So they're not going to dry to the exterior. So you need to keep that in mind when you're thinking about what to do in your rafters.
Is there such a thing as a rain screen for your roof to go between the sheathing and the?
Yeah, basically that's the ventilation. There's a bunch of different ways. So what Steve was talking about was a hot roof where you're not venting it, and that's the riskiest assembly. If you've ever seen someone do a vented roof assembly, they take those chutes. They're basically these styrofoam kind of barriers. They create an airspace that you can insulate against. It keeps the insulation away from the underside of the roof sheathing by an inch or two, and then that allows an air channel. So you have a soffit vent, a vent down at the bottom of the roof, and then a vent up at the top of your roof, and it allows air to flow through, and that will carry away any moisture that gets up in there. The other thing you can do is just completely leave your attic unconditioned. If you have a colonial with 2 floors and an attic, you can insulate the ceiling of your second floor and have your attic be completely unconditioned. And then there's plenty of room for moisture to get out. You need to air seal very carefully between the second floor and the attic, so you're not letting all that moist air up in there. But that's certainly a very safe assembly.
Another thermal question for you. Any tips for managing the stack effect in an old house? For example, bringing wood stove heat to higher floors?
If you air seal in the ceiling and air seal the basement, you're going to have less stack effect, basically, because it won't be chimneying through. Usually the stack effect is going to get driven somewhat by the chimney effect as well, where it's bringing air in, oftentimes in an old house, through the perimeter of the basement, and then it's leaking out through the ceiling in the second floor. So if you can slow that down, the heat will move up there slower as well.
I'm not sure if this person's trying to take advantage of the stack effect to bring the wood stove heat up to the top floors. I'm not sure.
That used to be done a lot too. They put grates in the floor to get the heat up to bedrooms.
Right.
You can also
try. Often in an old house, you'll be boiling on the second floor.
Yeah.
And freezing on the first.
And you can try destratifying, but it's not so easy in a house. There's no great ways to do it, to push the air back down to the first floor.
Right. Yeah, I don't know if we have a particularly clever answer to that, but yes, air sealing. If you want to get rid of the stack effect, that's air sealing.
All right, one last insulation question for you. What's the best DIY insulation for a homeowner to install on the rim joists?
There's a lot of things you can do. I mean, you can just, the easiest thing is probably to get some rigid insulation and just cut it so it fits between well, first of all, let's make sure everybody understands. The rim joist is the perimeter of your house. Your floor joist, your 2x10s or whatever, die into the rim It sits on top of the foundation. And it's notoriously a tough spot to air seal and to insulate. So the first thing to do is to make sure you're insulated well. I mean, is to make sure you're air sealed well. You can do that with the insulation, but just make sure that you're air sealing, because otherwise it's pretty pointless and again can be dangerous to insulate. Old houses stay in good shape because not necessarily because they were built so well, but because every winter when you turn the heat on, you're blasting heat through these poorly insulated and drafty assemblies and drying everything out. So when you start insulating, you are preventing that heat from blasting, from kiln drying basically your house every winter, which can save energy, but if you're not careful, it can cause problems. It can cause rot. So again, as Steve keeps saying, the best thing to do is to prevent air from moving. So again, the easiest thing, there's a lot of great tapes out there. Steve sells multiple versions of them that you can either tape from the inside, tape the wood to itself. There are tapes that'll stick to both wood and to concrete for shielding around the perimeter. I would say don't bother insulating until you're sure that you're air sealed well. And then once you do want to insulate again, I think the easiest thing is to sort of cut some rigid and just get some of that, 1-part spray foam, the stuff you can buy in a can from the hardware store. Cut it a little bit undersized, cut the foam a little bit undersized, stick it up there, and then basically use the spray foam both to seal it and also to glue it in place. Again, you can also use some of these tapes to do that as well.
Yeah, I think if you air seal everything first, I'm okay with using a mineral wool bat in that scenario too. It might be even easier to put in.
Right.
Certainly if you've never used can spray foam before, you probably end up with it all over you and it does not come out of anything.
Right.
You could also, we have a tape you can tape on the outside of the sheathing to the foundation, to the concrete. So if you have clapboard siding, if you pulled your lower few courses of siding, you could reseal that outside. That's going to be, project specific on what's doable. But that's a way too. And then it also keeps the ants and the mice from coming in as easily as well. Because you're keeping it on the outside, you're air sealed, weather sealed from the outside.
Yeah. That spot where the wood framing, where that rim joist hits the foundation, that is, almost universally the draftiest part of an old house.
Yeah. It gaps, it warps up, the mice come in, make little spaces.
And you just have to, and again, you have to be careful too that you're not trapping water or vapor somewhere bad. A lot of really old foundations, if it's a stone foundation, that it could easily be could easily be canted in. So any water that hits it is sort of getting carried inside. So you definitely wouldn't want to trap it. You wouldn't want to seal to the inside on that because you're trapping water in there.
Yeah, one additional thing on the basement idea there is know your humidity. So if you can have some kind of a humidity gauge where you can look at it and see where your relative humidity is in the basement, you're going to know if you're in a bad spot with mold. Right. And most basements are going to need a dehumidifier, but they just don't dry well. So,
what's a good target, Steve, for relative humidity for a basement
somewhere in the 50% range is great. If you get up over 70% is when you start to get into a place where you're going to see mold on wood and sheathing and anything like that. So if you can stay towards 50, it's going to go up and down seasonally. It rains a bunch outside, the humidity comes up inside, and then the dehumidifier brings it back down. As long as you're not staying above 70 for a few days in a row, you usually are pretty safe. You won't have any issues.
And those
go ahead, Heather.
Those humidity gauges are fairly inexpensive, right? You can get them for $20 or less to kind of keep
I use an old weather station in my basement. Has temperature, humidity, and barometric pressure, which I don't use, but temperature, humidity. Then it tells me where I am with the relative humidity and dew point a little bit. So
Yeah. Yeah. Any cheap hardware store hygrometer is fine. And if you want more, the price of more sophisticated monitors keeps going down. I've got one, you can't see it, but in my office right now, I've got it's called an Aware, AWAIR. It's an air monitor, air quality monitor, and it measures relative humidity and temperature, and it also measures CO2 and particulate matter and VOCs. And you can, there's an app I can check what it is anywhere in the world on my phone. And it was not, I can't remember how much it was, maybe $100, or maybe I'm not sure. But anyway, if it's again, data is the best way. Ongoing monitoring is the best way to have a sense of what's going on in your house.
I am noticing the time, and I cannot believe we have just a few minutes left. So I'm going to let you do your wrap up here, and then if we can squeeze in a last question or two, we will.
Okay, so I think I've already shown, one surface can perform 1 million and one. And again, like as we talked about with the vapor drive going both ways, you need to know what's going on in your climate to know what the conditions are and how to make those decisions. Trapping moisture is always dangerous. That doesn't mean you can't do it. Moisture barriers can be good or whatever, but you just need to know it's risky, and you need to know what you're doing and have a strategy for dealing with it. The continuity of layers is important. Gaps are where the problems can occur. Thermal bridges, which you didn't really talk about, but this idea of a material going from inside to outside and transporting heat, those are typically always can cause problems because they're colder than everything else, the condensation points, and they're also harder to air seal. And that's it. Shameless plug.
Awesome book. Great case studies, great photos. Two final questions to squeeze in. Okay. One is, do you want to do a final plug on the importance of ventilation? Because it seems like with everything you've said, that's going to be really key for a lot of folks doing renovations. The
importance of ventilation?
Ventilation.
Got it. Yeah, I mean, I would recommend, if you're concerned, get an air quality monitor and you'll learn. Even simple things like your bedroom, the CO2 levels can spike incredibly high overnight. 1,500, 2,000 higher. These are not healthy for you. There's often a lot of particulate matter in your kitchen, which is nasty stuff, and it can go, and basically under a certain size, it goes from into your lungs, and it goes directly into your bloodstream where it causes problems. It's small enough to pass that through. So ventilation, it's important, and again, it's getting easier and cheaper to implement some of these strategies.
All right, last question. This is a good one to end on. What is being done to combat embodied carbon emissions in residential construction?
Oh boy, not enough.
That's
Steve,
true.
You got any inspirational words?
I feel like there's at least some, there is somewhat more awareness in the building community, particularly in Maine, but most of the rest of the country, not so much. Some manufacturers, I think, have been, at least tried to improve their processes to lower their energy consumption, CO2 outputs on what they're making. It's always going to be about material choice if you really want to, have less of an impact when you're building. So local wood is going to be better than steel from away, that kind of thing.
Right. Yeah. But as Steve often says, the greenest house is the one that already exists. There's nothing particularly green, sustainable, whatever about building a new house. We still need to build them, but building detached single family homes is a very labor intensive and resource intensive process. And yeah, I mean, some people are doing incredible stuff, but 99.9% of it, you know, it's not doing the planet any favors.
Yeah, yeah, yeah. You know, I would love to see more builders and designers take up just doing it better instead of just building it. You know.
Well, you guys are helping. Your building science discussion group and the Pretty Good House book are going a long way to educating a whole new generation of builders and designers. So thank you, Dan and Steve. Thank you both for being here. This was a fantastic overview. I feel like we just scratched the surface, and I'm really glad you have the book cover plug here, because I do think that anyone who's joining us tonight, if you are curious to learn more, this book has a really great overview, and it does follow through the 4 control layers. Is that right, Dan?
Yeah, I
Same
mean,
organization.
yeah, I mean, there's more. Yes, it doesn't. Yeah, it hits a lot of other topics too, but it certainly hits those.
So thank you again to our sponsors, Royal River Heat Pumps and Senecal Construction Services. Thank you to Rayner, who's been handling everything behind the scenes so beautifully. Our next webinar is January 9th. It's going to be all about residential carpentry and construction training programs in Maine. We'll have Christy Crocker from the Indoor Air Quality Council talking about their residential construction training program. Anna Heath, founder of We Built This Carpentry Workshops, and Randy Rand, who's the training director for Passive House Maine. And there is more information about this session, as well as recordings from all of our past sessions on our website, greenmainhomes.com. If you do have any questions we didn't get to tonight, we will be sharing contact information for our panelists in a follow-up email, along with a link to the recording. And we will stick a couple of links to some articles that relate to topics that have come up tonight as well that might be helpful. And lastly, you will see a brief survey pop up when we close the webinar. We love your feedback. We'd love to hear how tonight's session was, and if you have any ideas to help us craft future programming. So thank you again, Dan and Steve, and thank you everyone for joining us.
Thank you.
Bye bye.
Bye-bye.